Next is case 5 for unsymmetrical cable which is supported at a different level. We need to find the horizontal and vertical direction for this case. The geometry are given as you can see here, 10 meter, 5 meter and the length is 4 meter, UDL 2 kN per meter. So we know this relation L1 divided by L2 D1 divided by V2 square root. We don't know the distance of L1 and L2, but the total length is given 40 meter. We know this one is D1 and this one is D2. So we take this distance as an x value. So the balance of that is 40 minus x. Then we substitute into this equation. Then we can get our x is 14.64 meter. Then we take for entire structure, take summation moment at A equal to 0. So here is A, positive clockwise. Due to UDL for 40 meter length, so 2 times 40 meter, then this length we have to divide by 2, so 40 divided by 2. This force is going down, so 2 point A is clockwise, therefore positive. Then for VB is going up, 2 point A is anti-clockwise, therefore negative VB, and perpendicular distance for that is 40 meter. Then for HB, to point A is clockwise, therefore positive HB. Distance for that is 10 meter. So arrange this, we get an equation. So HB equal to 4VB minus 160, we take as an equation 1. Next, we take half side, so we take segment CB. Then we take summation moment at C equal to 0, positive clockwise. So we know our x already 14.64. So 40 minus 14.64, we get 25.36 for this length. Then remember the formula of cantilever beam with UDL on it is WL square divided by 2. You learn that in theory of structure. So for that one, you are using here WL square divided by 2 for the UDL on this entire length. Then we have VB going up. 2 point C is anti-clockwise, so negative VB. Distance for that is 25.36. Then we have HB. 2 point C is clockwise, so plus HB. Perpendicular distance for that is 15 times by 15. Arrange this equation. So we have VB equal to 0.59 HB plus 25.36. So this for second equation. So we need to solve this simultaneous equation. Substitute equation 1 into 2. We get our VB is 50.76 kN. Then substitute VB into equation 1. We get our HB equal to 43.04 kN. Next, we have to take summation of Fx equal to 0, positive to the right. That means horizontal A minus horizontal B equal to 0, HA equal to HB. So our HA is 43.04 kN. Next, we take summation Fy equal to 0, positive upward. So our VA plus VB minus 2 kN, the entire length is 40 meter. equal to 0. We know our VB is 50.76 kilonewton. So we can solve this. So we get our VA is 29.24 kilonewton. Then we need to calculate the cable length. So we need to use this formula. So we know this L1, L2, D1 and D2 already. So simply substitute into this equation. So we get our cable length for this one is 47.05 meter. So we done determine the total length for case 4 and 5. Now we need to do for this question. For this question, we need to determine maximum uniform loading, which is W. W is not given to you. And what given to you here is cable capable to sustain a maximum tension of 15 kilonewton before it will break. For this one, you have to do as a group exercise and reply in Padlet together with your reflection for this week. So once again, 15 kilonewton is T max, and we need to find what is W, what is UDL for this case. For a brief, so we know VA equal to VB, WL divided by 2. So we're gonna have an equation here. Then we know HA equal to HB, WL square divided by HH. So we have another equation. Then we know our T max is H square plus V square square root. T max is given here 15 kilonewton. So finally, by solving those equations, we will get W equal to, so what is this UDL?